On this question, you're asked to find the error bound for the mean. So it says, assume that a sample is used to estimate a population mean, mu. Find the margin of error that corresponds to a sample size of 13 with a mean of 56.6 and a standard deviation of 6.8 at a confidence level of 90%. So in this case, what you always want to do is write down all the statistics that it gives you. We've got n equals 13, that's our sample size. Out of those 13, the mean is 56.6, so that's your X bar, and that sample has a standard deviation of 6.8. Because it gives us the sample standard deviation and not population standard deviation, we're going to have to use the student t distribution to find our critical value for our formula. So the formula you're going to use is similar to the one we used in the last section, except we're going to use the t critical value times the standard deviation divided by the square root of n. So over here in StatCrunch, I'm going to do stat calculators t, and that is simply because it gave me sample standard deviation instead of population standard deviation. When you pull up the t calculator, it's asked for df, which is your degrees of freedom. That is just your sample size minus 1. So because they gave me 13, my df will be 12. I'm going to change this to between, and then just like before, you're going to put your confidence level as a decimal in the last box. So I'm going to have 0.9 for 90% and compute. So here my t critical value, or my t alpha divided by 2, is 1.7823. So I'm going to use that. Don't use the negative one, use the positive one. I'm going to use that as my critical value. So I'm going to have 1.7823, and then you're going to multiply that by the sample standard deviation, which is 6.8, and divide by the square root of n, so square root of 13. And that will give you your error bound for the mean, and make sure you round appropriately, so this would be 3.4 as your final answer.